Hello students, welcome to Akshara Foundation. Today we are going to see all the concept based questions and exercise problems from synopsis 1 to 3. Okay, in the last class we have completed all the explanation about the magnetism. So now we are going to see first in synopsis 1 concept based questions and exercises we will see there. Okay. So in the synopsis 1 concept based questions, first one is given here, concept based questions. See, the first question is given here. Temporary magnets are made up of. Temporary magnets made up of. So here the soft iron is given, steel is given, stainless steel, copper. Okay. So it is a soft iron. Temporary magnets made by two materials, that is soft iron, and even we can say the electromagnet. Okay. So then soft iron and the electromagnet are the temporary magnets we have seen the concept. So first question option is 1. So first one it is. And second option you see in the concept based questions. Magnetic lines of forces are. First option is given are closed loops and continuous curves traveling east to west direction, always intersect each other, possess all of these properties. Okay. So here the bar magnet, see if this is a bar magnet there, we know that there are the two poles will be present there, north pole and south pole. North pole and south pole at the edges. Okay. So now here from this, from the north pole, the unit north pole will travel. Unit north pole will be passes from north pole to south pole, and inside the bar magnet, south pole to north pole, it will be travel there. Like this. Like this, it will be travel. Always the unit north pole will be keep on moves. So due to that motion of the unit north pole, it will be gives the force of attraction. Okay. So that is the reason why it has the magnetic power, it has the attraction power. So then here also the unit north pole will be travel like this. So this is in this direction and here it is like this. It is keep on like this. There are then it will be like this. These are known as magnetic lines of forces. These are known as the path of a unit north pole in the magnetic field or around the magnet. So due to that, there is the force of attraction of the magnetic power the bar magnet will have it has there. Okay. So then the north pole, from the north pole, inside the bar magnet they will be travel like this. Okay. From south pole to north pole, from south pole to north pole we can write like this. Okay. So it is south pole to north pole. These are known as the magnetic lines of forces. See, these are closed loop now. It is a closed loop we can see here. This is a closed loop. So that will the question is asked there. And here the options are given there. First one, always intersect each other, are closed and continuous curves, and travel in east and west direction. So here there are the closed and continuous curves there. And two magnetic lines of forces are they are not intersect each other there. Suppose if they intersect each other, then it is not possible. No, at one point there is two direction of the magnetic field does not exist. Okay, so that is the reason why these two magnetic lines of forces never intersect each other. They are the individual continuous closed curves. They are the individual continuous closed curves. The magnetic lines of forces are, we can say, they are closed loops. It is nothing closed circuit, no, closed loop. It is a closed loop or closed curves. So option is here, continuous closed curves. That is option 1. And third one. Among the following, the non-magnetic substance is called, okay, iron, cobalt, aluminum, nickel. So aluminum will be the non-magnetic. See, iron, cobalt, nickel are the magnetic materials. Iron, nickel, and cobalt. These are the magnetic materials. These are magnetic materials. Magnetic materials are nothing but what there? The materials which are attracted by the magnets. The materials are the substances which can attracted by the magnets is called the magnetic materials. Non-magnetic materials, we can say they are wood, plastic, and here silver, aluminum, and gold. These are all the non-magnetic materials. Non-magnetic materials. They are the non-magnetic materials. That means they does not attracted by the magnets. The materials are the substances which does not attracted by the magnets are known as the non-magnetic materials, which they attract. They are known as the magnetic materials. So the magnetic materials are iron, nickel, cobalt. Okay, and here wood, plastic, silver, aluminum, gold. They are the non-magnetic materials there. So from the given options, aluminum will be the non-magnetic material. Okay, so next, ceramic magnets are used. So computers, wall clocks, refrigerators, coolers. Ceramic magnets. So ceramic magnets are used. Ceramic is nothing but it is an alloy of two or more materials. So ceramic magnets are used in ceramic magnets there. So this is a fourth one. Ceramic magnets is used in refrigerators. Okay, ceramic magnets are used in refrigerators. Then this third one is what we can write here. That is aluminum. So aluminum is given here in the third option. So option 3 is correct for the third one, and fourth question is given here. Ceramic magnets are used in refrigerators. So it is refrigerator is third option. This is also third option. It is correct there. That is the refrigerators. Refrigerators. Okay, and fifth one. So fifth one is given here. Which of the following substances used to make a permanent magnets? Soft iron, steel, zinc, copper. Steel is used to make the permanent magnets there. Okay, so steel. So it is option 2 there. There is a steel. Steel will be the permanent magnet. And again, stainless steel is a non-magnetic material. Stainless steel is non-magnetic material, that you should remember. And the sixth one here. In electric cranes, the substance used to prepare an electromagnet is soft iron, steel, zinc, copper. In electric cranes, the substance it is used as a copper. Generally, we will use the copper there. Copper is the material which is used to prepare the electromagnets there. Okay, copper. If the copper coil is wound over the iron material, then it will act like, and two ends of the copper wire is connected to the electrical cell, then it will act like a magnet there. Okay, so then here which is the substance that will be used to make the permanent magnets there? Permanent magnet, that is over there. Okay, fifth one, and sixth one is given here. The question in electric cranes, what is the material is used to find the permanent magnets there? So generally it is in cranes. Normally, so the small bar magnets is used by the copper, and in electrical cranes, so means electrical cranes substance used to prepare an electromagnet. So that is a soft iron. So sixth one is here. To lift the heavy loads, it is a soft iron. Okay, soft iron will be the material that will be here. It is the first option is right. Sixth one is first option. And seventh one, natural magnet is also known as magnetic needle, bar magnet, lodestone, and disc magnet. Okay. So magnetic needle, lodestone. So lodestone is the natural magnet. Lodestone is the it is the natural magnet. There is a lodestone. Lodestone is the natural magnet. Okay. And eighth one is given here. Choose the correct statement. So first one is given here. The tin is a magnetic material. Tin is a magnetic material. Magnetic influence is stronger near the middle of the pot of a bar magnet. Magnets attract the stainless steel spoons. Attractive property is used in magnetic trains. Okay. So here attractive property used in magnetic trains there. So which one is the correct statement? From the following, which one is the correct statement? We need to find out there. So here it is. The magnetic influence is stronger near the middle part of the bar magnet. Okay. So correct statement is asking no. Tin is the magnetic influence is stronger near the middle part of the bar magnet. So it is not correct option there. So tin is a magnetic material and magnetic influence is a stronger near the middle. It is not stronger the middle there. At the edges, at the pole, it is a stronger there. Okay. So magnetic attracts stainless steel spoon. It will not attract. Stainless steel does not attract the magnets. So attractive property used in magnetic trains there. So this is the fourth one is correct. Attractive property is used in magnetic trains. So eighth one is a fourth option is right there, not two, second option. Okay. So now here ninth one is given. An ore of iron acts as a natural magnet, that is called there. Hematite, magnetite, both 1 and 2. And here there is a magnetite. Magnetite is the natural magnet. Okay. That we have seen already, no? Magnetite is the natural magnet there. So there is ninth one is the second option, that is called the magnetite. So ninth option is here the ninth option is option 2, magnetite. And 10th one is given here. There is a chemically natural magnet. The chemical formula of natural magnet. That is, we can write that magnetite. The formula of that is Fe3O4. Fe3O4. It is a magnetite. Magnetite. Okay, that is a concept-based questions. Now we will coming to the exercise problems. There, we see that here exercise problems. So these are all the exercise problems you can do there. So first we will see the single correct answer there. Exercise first question you see there here. So for this the first question is given. We do not use natural magnets in various devices because they are brittle and cannot be shaped. They have very weak magnetic strength, both 1 and 2. Okay, they are brittle. Generally, they are the brittle and so both 1 and 2 we can write here. So first one is option 3, both 1 and 2. So first option is 3, both 1 and 2 there. So natural magnet, like we have the magnetite and the lodestone are there, no? So they are the brittle in nature there. Means if the force is applied on them, they will be like crystals. They will be spread like a crystal there. They dispatches like a crystals and they have the weak magnetic strength there. So both are the correct there. So 1 and 2 is option 3 is correct there. So next question is given here. The substance that cannot be magnetized attracted by a powerful magnet or okay, the substance cannot be magnetized and attracted by a powerful magnet are called there. So that is the, we can say here ferromagnetic substances and paramagnetic substances, non-magnetic substances, none of them. So we can say that diamagnetic materials, they are known as non-magnetic materials there. So here the second one is also option 3 is a right one. It is a non-magnetic material. Okay. So here fourth one you see there. Sorry, it is a second one. Second one cannot be. Second one is the fourth is the correct answer. Second one is, fourth one is, sorry, this is also 3 only, third one only. Third one is the right one, non-magnetic material. So now see the third question. A metal scrap contains steel, copper, zinc, nickel and iron. The metals that can be removed from the scrap with the help of powerful magnets. Okay. So there are the scrap is there. In that scrap it is given there the steel and copper, zinc, nickel, iron. So which are they separated from that all the metal scrap. So which are the magnetic material, they can be separated by using the electromagnet, because electromagnet is a strong magnet. Then whenever the current passes through that coil there, it will act like a bar magnet. then all the magnetic materials can be attracted by it there. So here from the given uh, four substances, steel and the nickel and iron. So here steel and the nickel and iron, three materials they can be separated there. So remaining cannot be separated. So here, so steel, nickel, copper, they can be separated. So option 3. Third one is also option 3 there. They can be corrected. Then magnetic materials. So from the given substances which are the magnetic material, they can be separated easily by using the magnetic electromagnets there. Okay. Fourth one you see here. A magnet having the rectangular cross section is called there. A magnet having the rectangular cross section. It is called the bar magnet, horseshoe magnet, and electromagnet, magnetic needle. So it is the first option. That is first option, bar magnet. Bar magnet has the rectangular cross section. And magnet which is U-shaped and resembles horseshoe is called. So that is called the horseshoe magnet. It is called horseshoe magnet. So second option is right one. Means the magnet which is in the shape of U and which resembles the horse. Okay, horseshoe. So that is called the horseshoe magnet. So next one, fifth one is given here. Sixth one you see there. The magnets which lose their magnetism as soon as they cause producing them removed is called there. So they are the temporary magnet there. So by which the magnetic material is acting like a magnet. Okay, that cause is removed from that, then they will act like a temporary magnets. Okay, whenever the cause is there with the magnetic material, then they will act like a magnet there. The cause is removed, then they will be lost the magnetic property, that is called the temporary magnets. Okay, so here the sixth one is the first option. Sixth one is first option, temporary magnets. Seventh one you see here. Seventh one, the magnets. Which of the following is not a magnetic material? So nickel, cobalt, bismuth, and wood. So wood is the not magnetic material there. Okay. So there is option there. Seventh one is here. It is the fourth one and eighth one. You can see here eighth one. So which of the following is a permanent paramagnetic substance there? So phosphorus, water, platinum. So which are the paramagnetic substances? Paramagnetic substances are nothing but so which has the partial magnetic properties in that, and they will be attracted properly by the magnetic material. So we can write here. So eighth question is, eighth answer we can write here, that is the platinum. Platinum is the paramagnetic material there. Okay. And ninth one, which of the following is an artificial magnet there? Horseshoe magnet, magnetic needle, magnetic compass, and electromagnet, all of the above. Horseshoe magnet, magnetic needle. There are the artificial magnets only, all of the above we can add there. Ninth one is all of the above. So here the eighth one is what I said there, it is a fourth. So fourth is right answer. And ninth one is here we can add there fourth, that is all of the above. Okay. So now next questions we'll see here. So 10th one, magnets attracts substances which contains elements. They are known as what there? Iron, nickel, cobalt, all of them. Here also it is a fourth option we can say. And 11th one is which of the following elements can be made by the permanent magnets. Okay. So they are the iron, nickel, cobalt. They are by using them they are makes the permanent magnet there. All iron and nickel, cobalt, all of these are used to make the permanent magnets. And soft iron is it is not used to make permanent magnets because it loses its magnetization quickly. It retains magnetization for a long time, cannot be magnetized quickly, all of these. Okay, so it loses its magnetization quickly. So that is called, it is act like a temporary magnet there. So first option, 12th one is the first option. And 13th one, ferrite is used for making very powerful magnets. It is a mixture of. So ferrite is nothing but, so ferrite is a mixture of ferric oxide and the zinc oxide. Ferric oxide and the zinc oxide. Option 3. 13th one is option 3 there. So 13th one we can add here, that is option 3. Option 3. ferric oxide and the zinc oxide. So next, 14th question, which magnets are powerful? Artificial magnets, natural magnets, electromagnets. So electromagnets are powerful magnets. Natural magnets also, artificial magnets also powerful magnets than the natural magnets there. So even electromagnets are very powerful than the natural artificial magnet there. So magnet can attract through. So here the given options are glass, plastic, iron. So iron it is. The example of natural magnet is, so here the given options are magnetite. Magnetite is a natural magnet. So these are all the questions you can do there from the concept there. So then we'll be move to next synopsis 2. Now the synopsis 2, it is explains about the properties of the magnet that we have discussed in the last class. Now we'll see the concept based questions. The first question it is given there. Two common pins AB are made to stick to the south pole of the bar magnet. The pins will be okay. So stay as it is. They covers, see, two common pins A and B are made to stick to the south pole bar magnet. So they converge, diverges. Two pins will be, two common pins A and B are made to stick. So here the diagram is given like this. So this is the synopsis 2. The synopsis 2 will see here. Synopsis 2 will see now. Synopsis 2, the synopsis 2, first concept based questions, in the concept based questions, first question. So first question is given here, a bar magnet has here like this, and south pole is given there. Here two pins A and B are stick together. When they stick together, then what happens there? The two pins will be stick together, stay as it is, as in the given figure there, or the diverges outward will will cover as inward there. So how they will be seen there? That we need to say. So here they will be diverges outward. See, because here if the two pins are made here, no, this will be act so this is an north pole and here this is an north pole will be north pole like poles. These two will be act like a north poles. The north pole like poles will be repulse each other, so they will be diverges each other there. These two pins will be diverges each other. Okay, that is option 2. So first one is option 2. They will be diverges each other there. Two pins will be diverges each other because here south pole and these two pins will be act like they will be attracted. No? If they are attracted here, north pole and north pole, these two pins will be act like a north. Okay. So then they will be like poles. Like poles will be away from each other there. Okay. The two common pins A and B are made to stick either of the poles. So here also what happens there? North pole and south pole. So they will be converges. They will be converges. Here, suppose if it is a horseshoe magnet there. Suppose if it is the horseshoe magnet, and in the horseshoe magnet, so this is the north pole and this is the south pole. The two pins are made here, A and B. So what happens there here? This will be act like a south pole and this will be act like a north pole, and these two will be diverges each other. Okay, diverges each other there. Oh, sorry, converges. So they will be converges because they are not, it is a unlike poles, no, unlike poles will be attracts, like poles will be repulse. So here the repulsing means they will be diverges away from each other, and here they will be converges each other there. So here the option is what there, converges inwards. So it is a 3, option 3. So the attraction of magnetic substances by poles of magnet is, okay, maximum there. So attraction by the poles is magnet because the magnetic nature will be more at the poles there, at the edges of the bar magnets. So at the pole there is a attraction of magnetic substance of the poles is maximum. It is option 3. Third one is option 3. Option 3. So next one you see here. The Earth's magnet, its south pole is situated near. Earth's magnet has its south pole situated near to geographic north, geographic south, geographic west, geographic east. So Earth's magnet has a south pole situated. So it is south pole is situated geographic north there. So south pole of the Earth's magnet inside the Earth. So here Earth is a huge magnet. We will say this is the north and south. And here, if you consider a bar magnet, this is the south and north pole. It will be exist inside here. So that is the reason why this is a terrestrial magnetism of the Earth. So that is the reason why if you suspend a bar magnet by tied a thread, okay, by tying a thread and it is suspended on the surface of the Earth, the North Pole will be shows. So North Pole it will be towards shows the North Pole direction because inside of the bar magnet there is a South Pole will be there. So here geographical north is it is near to the bar magnet inside the Earth's magnet, Earth's South Pole. Okay, situated near to the South Pole is geographic north. So fifth one you see there here. The property that differentiates a magnet from other substances. Attractive property, directive property, and it is attractive property. Attractive property will be okay. It will be differentiate from other non-magnetic materials there. The directive property of a bar magnet was first used by okay soldiers, carpenters, musicians, and soilers. Soilers, it will be used by the soilers there. The ends of a bar magnets are tip of the magnets, vertices of the magnet, poles of magnets. There is a poles of magnet there. So at the edges, tip of the magnets are known as at the edges. There is a poles. Strong magnetic field will be there. They are known as the magnetic poles. The maximum magnetic strength of bar magnet is North Pole and South Pole. So there is A and B. It will be the fourth option will come there. And ninth one, freely suspended pivoted magnet will point the geographic north. Geographic north. So it is the north-south direction. So there is north-south direction there. That is option 3 we can add there. The sure test of the magnet. It is the repulsion. Repulsion is the sure test of the magnet. Okay. So that is about all about the concept based questions, and we will see now here exercise problems there. Exercise bits. So here the first question is given there in exercise problems. So first one. The physical property that characterize a magnet are. So it is a attractive property, directive property, pole property, all of this. So it is the physical property characterizes a magnet or attractive property, and that is called all of the above we can add there. If you hang a bar magnets and brings the bar magnets closer to each other, the north pole of one facing the south pole of other, then two will be attracts each other there. Two will be attract because the like poles are attracts like poles repulse each other, unlike poles will be attracts. So north pole are brought near to the south pole. Okay, south pole close to the south pole. Two hang bar magnets and brought each other with the north pole of the one facing to the south pole of the other facing there. So north pole, south pole, they will be attract there. Unlike poles can be attracts. Like poles will be repulsed. So they will be attract each other. If you hang two bar magnets, okay, there is over there. So repeat, and the closest to the south pole of the south pole, two, they will be repulse each other then. Okay, option 1. Which of the following properties of a magnet is used in navigation? Okay, that is due to the directional property. So due to the directional property, we can use to find the direction in the navigation. We'll use the magnetic compass. That magnetic compass it will be due to the directive property. It will be show the north, so that we can go in that direction. The magnet in the form of bar magnet, which is tapered from the center towards the ends, so pivoted at centers there, okay, is called there. The magnet in the form of a bar which are tapered from the center towards the ends there and pivoted, then its center on stand is called there. So bar magnet and horseshoe magnet, it is a bar magnet only. So two magnetic materials are tapered there at the center and at the edges. It will act like a bar magnet there. The small magnet needle pivoted at the center and encased in a small brass box with a glass top is called that. That is a magnetic compass. Magnetic compass. A small magnetic needle pivoted at the center and encased by a small brass box or a small aluminum box and with the glasses top. Okay, it's called the magnetic compass. It is called magnetic compass there. So now seventh one is the north pole of magnet. Bar magnet is taken towards the north pole of freely suspended magnet needle. The north pole of magnet will be okay. So it will move away from the bar magnet there. So here the first option is given there. Move towards the north pole and move away from the north pole. It will be north pole is brought near to the north pole of the bar magnet, which is it is placed horizontal, and another one is suspended by using the thread there. So then north pole are brought near to each other. They will be this suspended bar magnet will be moved away from the constant magnet which is placed near to it. And two magnets placed close to each other, as shown in the figure, which set will attract each other there. So which set will attract each other? They are saying there. So here the first set is given like this. In eighth question, the first one. So first set is given there here. So this is the north pole and south pole, and here also north pole, south pole. They will be repulse each other. North pole and south pole is kept here, and second one is placed here. So one is the north pole. Here also, this is the north pole is placed here. This is the north pole and here south pole, and here like this it is placed. This is the north pole and south pole. They are the repulse each other there, because like poles will be repulse each other and attract. Unlike poles will attract there. So they will be repulse each other. And in third one, what they have given here. So there also. So here two bar magnet, south pole and north pole, and here also north pole, south pole is kept there. So they also will be repulse each other. North pole, like poles will be repulse each other. And here next, the fourth one. How they have kept there? So here it is the north pole and here it is south pole there. So this is the north pole, south pole has kept, and here south pole, north pole has kept there. So they are the what? Right? They are the unlike poles attracts there. So they will be attract there. So in this one, they will be stick together. Okay. In all remaining diagrams, they will be repulse each other there. So which of the following figures does not show poles correctly? Okay. So here the horseshoe magnet, it can be show the magnet, and here cuboid also it will be show the bar magnet, and this one poles. Okay. So here third one circular like a ring type magnet, it does not show exactly, and here this cylindrical shape. Okay, they will act like a poles. So here we can say which one does not show poles correctly. So there is third one we can write here. It is the ninth one. Is third one, poles. In the ring shape magnets, it does not show the particular poles there. So cylindrical magnet, one side is the north pole and the other side will be the south pole, we can see. But in horseshoe magnet also, one side north pole and other side will be the south pole. And bar magnet, cuboid shape means it also show one side north pole and other side will be the south pole there. So any material here, 10th one is given there. Any material that attracts iron lines in the north-south direction suspended. That is called there. It is a magnetic substance. Non-magnetic substance. Magnet. A material that attracts the iron and aligns the north-south direction when they suspend. It is a magnet there. Okay. Magnet if suspended, then it will be aligned in the north-south direction there. And 11th one is given there. Following magnetic materials are very feebly attracted by a strong magnets. Okay, they are the ferromagnetic. Diamagnetic means it is a non-magnetic materials. Ferro means strongly they can be attracted, and paramagnets are partially they will be attracted. And an imaginary and line joining of magnetic north-south pole, all called there imaginary lines. So they are the magnetic lines of forces. The imaginary line of magnetic north poles of bar magnet is called there. So that is the magnetic axis there. The imaginary line which is joins the north and south pole, means poles of the bar magnet are known as here the magnetic axis there. And now the exercise here, second exercise is given here. There is a distance between the two magnetic poles is called the magnetic length. Okay, we have seen the last expression. Actual length of the bar magnet is nothing but the distance between the edges there. Geometrical length is called the geometrical length of the bar magnet there. And here the magnetic length means the distance between the pole, center of the one edge and center of the other edge. Okay, that is called the distance between the magnetic length and the geometric length there. So they have the relation between the geometrical length and the magnetic length. That is, so magnetic length is equals to the 5 by 6 times of the geometrical length. That we have seen now. So magnetic length is always lesser than the geometric length. Geometric length will be greater, magnetic length will be lesser because geometrical length is 5 by 6 times of the geometrical length. The ability of pole magnet attract or repel another magnetic pole is called the pole strength. The ability or the strength of a pole which attracts or repels each other, that is called the magnetic pole strength. Choose the correct statement is given here. Bar magnet always points towards the southeast direction. Glass is a magnetic material. A magnet has two poles, like poles attracts each other. So the third one is correct there. There is magnet has two poles, okay, pair poles. Pole strength is a dash quantity, vector quantity, scalar quantity, tensor and non, okay, not. So pole strength is a scalar quantity. Pole strength is a scalar quantity, okay. So because it is not in particular direction, all the direction it will be there, no. And two magnets have their lengths in the ratio 2:3 and their pole strengths are in the ratio 3:4. Their magnetic moment. So magnetic moment is nothing but, so magnetic moment is denoted by here capital M. This is a magnetic moment. Magnetic moment. So moment of bar magnet, otherwise we can say that is nothing but here the product of pole strength and the distance between the magnetic length. Product of pole strength and the magnetic length is called the magnetic pole strength. Okay. So now here they have given there two, they are in the ratio, magnetic length in the ratio 3/2 and they are asking the magnetic moments. So now here the magnetic length M is directly proportional to L. So we can write here M1 by M2 is equals to L1 by L2 we can write here. And so this one magnet, that is here even we can write here into M1 by pole strength is we can write here M1 by M2 only. So L1 by L2 how much they given there? Lengths are in the ratio 2:3 and here this is a 2:3 and magnetic pole strengths are given in the ratio that is 3:4. There these two will be cancelled and here 1/2 will be there. That is a 1/2 will be the answer. So magnetic moment are in the ratio 1:3. That is the answer there. So like this we have the second one is also same like that, 19th one is also same and next one numerical type answers are there, they are also same. So it is of 5 times, x is what there 5 times. So the magnetic length is 5 by 6 times of the geometrical length, they are asking what is the x there, x by 6 is given, so x is equal to 5 there. The magnetic length of bar magnet is 10 centimeters, geometrical length means, so 60 by 5 we can write there, 60 by 5 means how much we get there? 60 by 5, we can write there 12 centimeters. So bar magnet magnetic moment is magnetic moment is given there and is pole and pole strength. Pole strength they are asking there 0.2. So 0.2 by pole strength is nothing but we can write it 0.2 meters. So 5 by 0.2 meters. 0.2 means 10 will be goes up 50, 25 ampere meter, 25 ampere meter will come there. Okay, that is about the synopsis 2. And now we will see their synopsis 3, last synopsis. So synopsis 3, it will be explains about the methods of magnetization and demagnetization. Okay, so here we will see now concept based questions. Synopsis 3. So first we will see the concept based questions and then we will go for the exercise problems. So first one is see here, a magnetic keeper is a person who looks after the magnets, a piece of aluminum that is placed at the ends of two power magnets, a piece of steel that is placed at the center, placed at the ends of the two power magnets. So magnetic keeper. Okay. So it is nothing but a piece of aluminum that is placed at the ends of the two bar magnets, or a piece of steel. That is a piece of steel, it will be uh, kept. So magnetic keepers will be there now for, we have seen there like for the handbags, for the flip cover, for the all magnet will be there. So there is a steel, a bar magnet will be kept near to the, means steel will be kept near to the bar magnet. So that will be act like a magnetic keeper. The method used to demagnetization, heating, hammering, both 1 and 2. Both 1 and 2. How the magnetization can be demagnetized? A magnetized material, magnet, can be demagnetized by using the hammering and heating. There are many methods we have discussed. No? So here, both are given there, heating and hammering. Those two will be the methods of demagnetization. And third one is given there, a tiny magnet always has two poles. Any magnet, it has two poles there because the magnet has pair pole property. And fourth one is given here, the substance that cannot be magnetized or attracted by a powerful magnet are known as non-magnetic materials. Here we can see their diamagnetic materials also we can see. And fifth one is given there, metal scrap is contains steel. Already we have discussed in the last synopsis. Okay, steel, nickel and iron, copper, they can be separated. The magnetic materials can be separated by the strong magnetic material. So a bar magnet is heated strongly, then magnetic strength will be decreases. It will be decreases, likely to decrease. An iron wire is taken out and then towards the south pole, it is freely suspended, then it will be. So iron wire is taken towards the north pole of and then towards the south pole of freely suspended magnet. The poles of the magnetic needle, there, okay. So not affected by the iron and repel each other. They will be attracted, no, first north pole. So north pole will be attracted there, okay. Then afterwards it will be brought near to the south pole. Then it will be attracts there. So here it is, seventh one is given that is it will be attracted by the iron wire. So they are attracted by the iron because it is a magnet. Iron is a magnetic material, so it will be attracts there. Permanent bar magnet is rubbed by many times, and the steel bar is also known as that is. So south pole is rubbed many times. No, then it will be like a north pole property. Okay. So in the single touch method, the magnet will be touched, no. So south pole of the bar magnet is touched means it will be act like a south pole. And ninth one, which of the following used for making up temporary magnets? Already we have discussed. This is a soft iron. Okay, in the last synopsis. And few common pins are placed on the table with a glass top. The common pins will be moved opposite to the direction of the magnet. Moves direction of the magnet. Do not move, and throw up in the air there. So if it is placed bar magnet at the top, then all the pins will be moved towards the direction of the magnetic pin. So here we can write there option 2. So now we'll see, that is about the concept based questions, and here you see the exercise problem there. So the polarity induced in the at the end of D of a soft wire there. So bar magnet is kept there at the end of D. So bar magnet, here two bar magnets are given there. Exercise here, first question you see. So in the diagram they have mentioned here it is a bar magnet. So this is a bar magnet. This is a bar magnet. In the bar magnet, what will be happening there? This is a A and this is a B is given here. It will be south pole, north pole generally, and here. So there is a here there is a C and D is given there. At the end of here, what the magnetic property, magnetic pole, it will be there. So if it is here south pole, this will be like a north pole and it will be like a south pole. So at the end of day, it will be act like a south pole. Soft iron now. Then this part will act like a, then if the bar magnet is there no here, so then here it will act like a north pole and here other end. At the D it is south pole, it will act like a south pole. So we can magnetize a magnetic substance without touching it by a magnet by. So we can magnetize a magnetic substance without touching. So that is called the induction method. So we can have there magnetic induction. That is called, second one is magnetic induction there. So we have different four types of magnetization, magnetic methods, methods to magnetize magnetic material there. So there is four types are there, in that without in contact, physically contact there is a magnetization will be takes place. That is called the magnetic induction. To make a powerful magnets, there are is used alloy is called there. Alkino. So alkino means aluminum, nickel, and cobalt. Okay, they are the alloy of three metals: aluminum, nickel, cobalt. Alkino. So sorry, alnico. Electromagnets are used. So loudspeakers, doorbells, cabinet doors. So we connect here loudspeakers and the doorbells. Okay. So then both 1 and 2 we connect here. Electromagnets depends upon strength of electric current, number of turns wound on the magnetic material, shape. Okay. So now, so we connect here the strength of number of turns wound and shape of a bar magnet there. So we connect here it is a strength. It depends on strength of electric current and the number of magnetic number of wounds on the magnetic material there. Okay, that is both 1 and 2 we connect here. Soft iron pieces are placed across the ends of bar magnets, which shows presentive, keepers, and compass poles. The soft iron pieces are placed across the ends of bar magnets, which shows the presentive, keepers, and compass and poles. So this soft iron pieces will act like a temporary magnets, no? So they will be act like a keepers there. So which of these following does not contain a magnet? Torch, radio, fan, and both 1 and 2. So torch also has magnet, and here fan will have the magnet. So torch does not have it. In the torch there is no need of magnet. In the radio there is a magnet will be there in the speakers, and in the fan also there is a magnet will be there. So due to that only it will be act like a motor, magnetic. Okay. So then the first one is, 8th one is the first option. 9th one you see here, a keeper is used too. So it will be restore its provide a closed path, flux, change in direction of the magnetic lines there. So it will be restores the last flux there. So option 3 we correct. 9th one is option 3. The polarity of magnet depends on direction of the current flow, nature of material, shape of coil, and none. Okay. So direction of magnet. The polarity of a magnet depends on direction of current flow. It is a direction of polarity. Polarity of the magnet depends on the direction of the current. There in the direction of the current, based on the direction of the current, the polarity of the electromagnet will be changed. Doorbells used electromagnets there. Okay. The magnetic materials, magnetic lines of field lines. So they are given their properties of magnetic lines of forces. The intersect at right angles to each other, do not cross each other and cross. So it is option 3. They do not cross each other. I said no, the magnetic lines of forces are the path of a unit north pole in the magnetic field. Okay, then they form a closed loop and never intersect each other. Okay, if they intersect each other, there is a possibility of 2 directions. It is not possible there. Okay, that is the reason why they are never intersect each other, and they are the closed loops. And bar magnet hammered, sometimes then magnetic strength will be decreases. The loss of magnet property of magnet is called their demagnetization. Okay. So then 6th one is given here, magnetic lines of forces inside the bar magnet. They will move from south to north direction inside the bar magnet. I have shown in the diagram. A compass points north because the Earth's magnetic material. It will be the south pole of the Earth. Inside the Earth, there is a terrestrial magnet will be there. That is the south pole. So that the bar magnet, north pole of a bar magnet, always it will be points toward the geographical north. So you are given two similar unmarked bars. Of one of them is magnet, while other magnetic material without any other aid. So how would you deduce which one of the magnet is a magnet there? So by placing two bar parallel to each other, by placing the tip of the bar magnets near to other bar magnets such that they can be replaced. So we can say here they will be placing the tip of one of the bar magnet middle of the other point. So if you place one of the bar magnet near to the other one, they will be, so we can recognize them, which one is the bar magnet or not. Okay, result. 18th one and 19th one, a strong bar magnet is placed vertically above the horizontal wooden board. The magnetic lines of forces will be only horizontal plane or around the bar magnet, or only vertical plane around the bar magnet. A strong magnet placed vertically above. So above the horizontal wooden board. So they will be act like if a bar magnet is placed vertically, then all the magnetic lines of forces will be seen vertically. So if we take a steel sewing needle, stroke for 20 to 30 times the same direction, which end of the magnet? So if you take a steel sewing needle and stroke for 20 to 30 times in the same direction, so with one end of a magnet, then so the needle will be demagnetized. No, the needle will be magnetized. It will be pick up the pins ellipse and one and two here. So if it is hammered, the swing will be hammered to the bar magnet, so it will be demagnetized there. We need the two magnets magnetic in the method. So single touch method, double touch method, electrical and the induction method. So it is a single touch method, we needed two bar magnets there. In single touch method, by rubbing the permanent magnet over the steel strip, then in east to west direction, north to west direction, that is, so it is the north to south direction. If it is north to south direction, if it is rubbed, then it will become a permanent magnet there. Okay, these are all about the synopsis in the magnetism. Okay, so the magnetism is completed and we are going to see the next chapter. Okay, so thank you children, have a nice day.